mostly because I don't think I spent nearly enough time in the library at Oxford. When I was there, we also start our coders very young. This is one of our prodigies.
Company.
See, you actually know if that was a joke. That's good. We built software to augment intelligence, to let people plug in and play with high-dimensional data, to really start to understand and upload this information into their brains. And we've got a range of companies that we work with, everyone from Red Bull through to the Department of Defense. And I can say they have actually quite different cultures, in case you were wondering. But they've been great, and it's been a fantastic journey kind of rolling the software out, and we've learned a lot as we've done this, bringing some of the first commercial augmented intelligence software to the market and bringing it to the world and helping them solve problems like what is China really doing with bioinformatics and how might that affect cryptography, through to what is the narratives that people really talk about when they talk about family dinners and how do we make Red Lobster in a place where it can actually take advantage of that. So we get the whole range of questions, which I think keeps life kind of interesting. But people are able to plug into the software and actually start to answer quite complex questions. One of the little companies that are using the software is a company you might have heard of. It's a company called NASA. Those guys, they sent someone up to the moon, allegedly.
Did you check that?
Yeah, they told me they did, but that's exactly what they would say, right? No, so we worked with them, and then they start to drive the software, and they start to drive it because they're really trying to understand what is going to happen where they don't have the dominance of the industry of sending people into space. In fact, they're already there because they can't send people into space at the moment. But they really want to understand what happens to their global industry when SpaceX and Orbital Science and Sierra Nevada start to create the capability of bringing people up to the space station. It's an incredibly difficult problem, and it's one that NASA bets around $10 billion a year on. So of course it has a massive implication for what they do and how they do it. If you were to start to research this, you'd traditionally go down and you'd go into Google and you'd type space industry, and you'd get back 4,500 articles. And Google would proudly proclaim that it did it in 0.17 of a second, and you'd feel kind of comfortable with that. And then you sort of realize that those 4,500 articles will take you the best part of the next 3 weeks to read. And the 0.17 kind of seems irrelevant at that point. Because we're trying to wrap our heads around something that's very complex. We're not trying to find the one article. We're trying to understand the entirety of the industry. So we really want to think about, instead of creating a list of that information, how do we turn those 4,200 articles into an interactive, dynamic, human-centered user interface, one that we as humans can start to connect with and understand. And so to do that, we take all the information that's in the web pages that we crawl, we pull it out, we start to use natural language processing to extract out the core concepts that are existing within those articles. We train computers to sort of understand what the articles are really about. And that gives them a sort of a digital signature, a footprint or a fingerprint that is unique to that article. And with that, we can actually make comparisons to all the other articles to start to compare whether or not these things are very similar or not. If we find a match and they are similar, we're able to represent that as a graph structure, a two-dimensional projection of that information onto our page. So that's kind of what, that's the theory behind it. But let's take a look. Let's take a look at those 4,500 articles and see what they actually tell us. And from this, we should actually hopefully be able to understand something about the global space industry, but hopefully a lot more than just something. We should actually hopefully also get some nuance out of it as well. So here's the Quid software in action, and you can kind of see all the dots represent news articles. You can go through and interact and click on any one of them and kind of see what they're about. They're all kind of sized the same at the moment, but they've got connections, so when things are similar, they connect to each other, and you can kind of see those connections operating there. But some of them have more connections than others, so we can change the size of the nodes to represent things that have different numbers of connections. At the moment, they're all spatially the same, but we want to apply a physics engine to this and start to kind of find articles that are similar coming clustering together and articles that are different flying apart. And now all of a sudden, what was a sort of an amorphous blob becomes a structured piece of information, one that we can go through and apply clustering algorithms to create different colors. And the different colors represent different topics that are being discussed around the global space industry. Now, instead of just having a map of geography, we've got a map of all the ideas that are shared. And we can zoom in